Hey everyone, welcome back, and today we are going to dive into the world of units and physical quantities. Last time we talked briefly about the important role that experiments play in physics, and one thing that experiments usually do is make measurements. So it becomes extremely important that we understand how physical quantities and units work. Well, first, you should probably know that a physical quantity, as the name suggests, is just any old number that describes a physical phenomenon. So basically, every number you see around you is or is related to a physical quantity. Clocks help you keep track of time, thermometers tell you how hot or cold things are, and the weighing scale keeps track of your self esteem. Well, I'm sorry, I meant weight. And roughly speaking, physical quantities can be split into two categories: the fundamental physical quantities and everything else that is derived from the fundamental ones. And how do you tell the difference? Well, the fundamental physical quantities can usually only be defined by how they are measured. These definitions are called operational definitions. And the three fundamental quantities we are going to talk about in more detail are time, length, and mass. And if you think about it, it's kind of impossible to define these quantities without mentioning some device or some thing that we use to measure them. Just try going up to a friend and asking them, "Hey, Liz, what is time?" Well, chances are they'll be stumped and end up not being able to say anything beyond, uh, something we measure with a stopwatch? But on the other hand, if you ask the same friend, "Hey, what is speed?" they might have a better handle on that one. They might say, distance over time or something along those lines. And why is that? Well, that's because speed is a derived quantity, specifically one that is derived from relating the fundamental quantities of length and time together. Okay, so let's talk about units. A unit is a standard that we've all agreed on so that physical quantities can be meaningfully measured by making comparisons to them. For instance, when you say that someone is 5'6" or 168 centimeters for lovers of the metric system out there, what you mean is that they are as tall as 5 times a foot plus 6 times an inch, where a foot and an inch are both some standard of length that we've all agreed on. Equivalently, 168 centimeters means that they are as tall as 168 times a centimeter, where a centimeter is once again some length that we've agreed on. A foot, an inch, a centimeter. These are all examples of units. Units, in this case, that help us measure the quantity of length. And for lovers of the metric system out there, I have good news. In physics, we pretty much exclusively use the metric system, or what is more formally known as the SI system, or the international system. Okay, now let's go back and talk a little bit more about the three fundamental quantities we mentioned earlier, and how we've defined their standard units. First, time. Of course, there are many, many units of time that we use on a daily basis. For example, what I just said, daily, or a day, is a unit of time that we use on a daily basis. And there I am being meta. But anyway, other examples include year, month, hour, fortnight, even. But physicists came to an agreement that the second should be our base unit, or the most fundamental unit of measure when it comes to time. In other words, all of the other units of time are actually defined in terms of the second. A minute is exactly 60 seconds, and an hour is exactly 60 minutes, and so on and so forth. But how do we define precisely what 1 second is? Well, it turns out that coming up with such a precise timekeeper is quite challenging. But for now, we've agreed that 1 second is defined to be the duration of 9,192,631,770 periods of microwave radiation of a very particular frequency corresponding to the transition between the two hyperfine levels of the ground state of the cesium-133 atom. Well, first of all, don't worry about writing that down or even understanding what that means exactly. Nobody is going to test you on the precise definition of 1 second. Well, hopefully anyway. But it is important to know that the second is the base unit for the fundamental quantity of time, and that it is defined very, very precisely. Similarly for length, we have a lot of different units that we use, like the inch, foot, mile, or if you're not from one of the 3 or 4 countries that use the imperial system today, a centimeter, kilometer, etc. But physicists have once again agreed to use the meter as our base unit for length, so that all other units are defined in terms of the meter. And the meter is defined to be the distance traveled by light in 1 divided by 299,792,458 seconds. I actually really like this definition because it is a pretty quick application of the formula that speed is distance over time, and we cleverly use the fact that the speed of light is constant. Physicists have agreed to define the speed of light, c, to be exactly 299,792,458 meters per second. And now that we've defined the second very precisely, we can define the meter in terms of the second, which I think is a really clever way of defining a physical quantity. And finally, we have mass, the third fundamental quantity we will talk about. Once again, there's many units of mass, like pounds or grams, but physicists have settled on using the kilogram as our base unit. I won't go into the details of how the kilogram is defined, but the idea is pretty similar. Since we've defined the meter and the second very precisely, we can now define the kilogram in terms of those, and defining that another fundamental constant, called the Planck constant, h, be exactly 6.6260715 times 10 to the negative 34 joules seconds. Anyway, the key takeaways from this whole discussion are that time, length, and mass are fundamental physical quantities, and that the second, the meter, and the kilogram are respectively the base units for those quantities, which are all defined very, very precisely. And now that we have base units for the fundamental quantities, defining units for the other derived quantities is an easy task. For instance, following the equation speed is distance over time, we can figure out that the base unit for speed is meters divided by seconds, or meters per second. We will meet many more derived SI units as we continue our introductory physics journey, and we will derive those units in a similar manner. The final thing we discuss in this video is about unit prefixes. Now that we have base units, we should have a convenient way to talk about units that are smaller or larger than the base unit. That is exactly what prefixes do for us. For example, we have the kilometer, which is the prefix kilo attached in front of one of our base units, the meter. Kilo is a prefix that means 1,000, so a kilometer is equal to 1,000 meters. An example that goes smaller is the centimeter. The prefix centi attached to the same base unit, the meter. Centi is a prefix that means 100th of, so a centimeter is 100 times smaller than a meter. Another way to think about that is that 100 centimeters is equal to 1 meter. Finally, here we display a table of prefixes and what they mean. It is really convenient because these prefixes are common across all units. So, for example, a kilogram is 1,000 grams, but a kilometer is 1,000 meters, and although very rarely used, a kilosecond is 1,000 seconds. You will encounter these prefixes throughout your physics journey, so this table might be worth memorizing or at least having it in the back of your pocket. Alright, so in this video, we introduce you to the wonderful world of physical quantities and units, which we will use literally all the time in physics. And we talked briefly about the difference between a fundamental and derived physical quantity. And we met the big three fundamental quantities: time, which is measured in seconds, length, which is measured in meters, and finally mass, which is measured in kilograms. And finally, we talked about how to use unit prefixes to make a base unit smaller or larger when that is convenient for us. And with that, see you next time when we will talk more about units.